Good morning, all. Myself Krishna, and today's session is all about machine learning. So first, we can start with how to define machine learning. So machine learning is subset of AI. It involves developing algorithm that allow machine to learn from data and perform tasks without being explicitly programmed from those specific tasks. So we have some set of algorithm given in machine learning. We will be talking in our consecutive slides, and based on those algorithm, we are going to find out right model based on the existing data sets, and we train our model. And once our model is trained, we can predict the value. So this is all we used to do. We used to set up some algorithm for the machine to predict some unknown data. Coming to deep learning, once you covered machine learning, you can go with deep learning. Deep learning mostly is a subset of machine learning where you are mostly talking if your data set is quite large, yeah, if you want to process image, text, for text processing, we have neural network. For image, we have CNN. Um, like for speech recognition, audio, all those things we can do in deep learning. Coming to AI is subfield of data science and computer science, and it is broader field that encompass a variety of technique and approach aimed at creating system capable of performing tasks that typically require human intelligence, such as understanding neural network, recognition pattern, solving problem, and making decision. So if you see this diagram, this is machine learning, this is deep learning, like deep learning subset of machine learning, and this is totally, if you visualize this in 3D, you can say it's all part of AI. So in machine learning, we have two branches, supervised learning and supervised learning. So in the supervised learning, we used to train our model based on label dataset, and unsupervised learning, we train our model based on unlabeled dataset. So what do you mean label dataset? So label dataset set is going to have features and target. So just think you have set of dataset, and there you can have number of columns. In the number of columns, some columns will be your feature and some will be your target. So whenever you are getting data, you try to plot in X and Y axis, right? So here what we are doing, we are going to predict Y value based on the feature value. So just think one simple example. It is age and salary, and for 23 age, 45K salary, and you have to predict for what could be the salary for age 50. So we have many different way. We will be talking when we will go to algorithm, like when your data set is linear, yeah, non-linear, what algorithm you are going to follow, how you can find out best fitment, best formula to predict unknown value. So when we say label dataset, it means you are going to have the features and target. Unlabeled dataset, it means there is no feature and target here. It can have number of columns with data here, and what this machine model is going to do, it is going to predict some pattern. Like here, you can do the grouping based on annual income, do the grouping based on spending score, like that. So when we talk supervised, um, we have two type of supervised. One is classification, regression. In the classification, our outcome will be binary. Like I said, for the supervised learning, we are going to have label dataset. In the label dataset, it will be feature and target. And for the feature, here for the classification, uh, your target will be a binary, Boolean. Yeah, it could be means your outcome will be Boolean, yeah, binary. The algorithm you will be following for classification, that is logistic regression, decision tree, random tree, SVM, neural network. So just think this is the data set, and here you, based on this feature data, you are predicting the whether this is a heart patient, yeah, non-heart patient. So here you can see the outcome is no, yes, right? Regression, your data, your prediction will be numerical. I mean, based on, I mean, it will be discrete, yeah, continuous value, your outcome. So just think here you have some flat costing based on square feet, number of bedroom, age of house, and you have to predict new structure. I mean, for 2,500 square feet, if somebody expecting 5 bedroom and age of house is 12 years, what would be the price? So once you build your model, you can predict a new data set here. Clustering is unsupervised. So like I said, unsupervised, you're gonna have uh, you are training your model based on unlabeled data set. So here we can use algorithm k-mean, hierarchical clustering, TBS scan. So this is the data, customer age, annual income, spending score, and just if you need to find out some pattern, I mean grouping of customer based on spending score. Yeah, other example you can take, like you have data for number of dogs, you have data for some set of cats. So what this model will do, it will going to create two cluster, one for dog, one for cat. And if you are giving them again dog, it will find out attribute for dog and it will map to dog cluster. Association is about it is trying to figure out relation between two data point, and it is going to, this model, it will eventually suggest provide suggestion. Like if you are watching movie over Netflix, and sometimes you could see the suggestion. So what happened here over the period, when you start watching, it is making a history of your movie, like what sort of movie you are watching, whether it is science fiction, yes, yeah, spiritual, yeah, uh, any movie, it will try to find out what sort of movie you are watching, and it will group, and based on that grouping it will suggest some new movie for you. So in this example you can see some transaction happen for bread, milk, diaper, beer, egg, and you can see first transaction beer, milk, second beer, diaper, I mean bread, diaper, beer, egg. So in the first transaction, if you can see, diaper is all across of all the 5 transactions. So the person who brought bread, milk, maybe he will like diaper. So this machine language will suggest diaper as well. Now coming to workflow of machine learning project. So in machine learning project, we can have data set, data pre-processing, then data analysis, training, test split, machine learning model, evaluation. So what are data sets? So the data, read raw data we used to receive from data lake, yeah, any of the source system, target system, any sort of data, whatever we are getting for our machine to learn, that we call data set. Data pre-processing is indeed needed. We need to do some analysis, like if any impute value, yeah, missing value, yeah, if layout is so. So first we need to understand about data. So in the pre-processing and data analysis, we are trying to find out the structural layout. We are using um, using some statistic for filling missing value. Yeah, we can drop those missing value. So what mechanism we use to for the imputation, we follow mean, median, mode. Like if some data set has missing value, we can use mean, median, mode to fill the value. So mean, just to highlight mean, you know, this is list of items, so it will sum all the list of items slash number of item is equal to. So this is how mean will be calculated. Medium, it will add do the sorting first, and then it will grab the mid value. And if there are two mid value, like here for this example, two mid value are eligible for 5, it will take mean. Mode is like it will look for repetitive uh, repetitive uh, data, and if there is no repetition, there is no mode. Here we have repetition, you can see mode is 2. Here mode is 1 2 3 because 1 2 3 have repeated in this array. Coming to train test split. So what happened here when we saw talk about train test split? This is very important in machine learning. So in machine learning, whenever you are giving the data, in the data, it will pick some sort of data for training and some data for the test. So what happened, just think you have 100 records, so 80% it will pick for training the model, and 20% it will keep for test data. So once your model is trained, it will try to find out accuracy with your test data, so that we can say this model is very accurate. Yeah, very accurately calculating. Yeah, this model has any flaw. So based on the test data, we will get to know this all. Once I will switch to Python code, I will be telling how we can plot XY. So this is for data standardization. Sometimes we need to auto scale data. So just think you have data for diabetes patient, yeah, for the heart patient, any data set you have, the scaling is different. The measurement is different. So what we can do is it is sometimes we need to standardize the data, and to standardize the data, we are following this formula. This is actual value minus mean, um, divided this population density. So just think, just to explain how this is working. So if you see this data where we have height and width. So your generally Panda be used for doing all sort of data analysis. So we extensively use Panda and NumPy for data analysis. So here you can see a scalar client you can create. You don't need to write code for data standardization. You can simply use this client, and through this client you can pass your standardized data. It will give you height and weight in a standardized format. But just to explain how this is calculated, this has calculated with this formula. Okay, and this formula, before going to this formula, you need to know the mean and you need to know the population density. So just we can stick to this value, how it has calculated. So first you can take the mean of, like for the heights, we have this data, take mean. I mean, sum of all the items slash number of items. So your mean will be 170. Nice. So coming to a standard deviation, we have, this is the formula of 1 by n summation of I is equal to 1 to n xi actual record minus x mean record and square root. Whole square, then square root. So if you see here, this is a square root. I don't know how to type here, so I have just uh, written square root. And here 150 minus 170 mean we calculated square root. Then 160, 170 square root. So this will come around 140.41. And when you calculate this standardized data standardization, which will be actual minus mean divided by this white population. So if you see here, 150 is first data minus 170 mean 170 and divided by 140.41, which will come around minus 1.414, this value. So this is how you can standardize the data. Coming to label encoding, in the label encoding, you can see we have data for red, green, blue. So what we are doing, we are transitioning data from string to numeric. This is all like for zero, for red we are calling zero, green we are saying one, blue we are saying two. We are not extensively using this label encoding, but some place it is required you can use. So just for the concept, in the label encoding, your data you are translating to numerical format. So this is for um, this I will explain when I will go to Python Visual Builder, where I will explain how this is working through code. Imbalance data concept is like whenever you have, like here, one example, you can take one class has 90% um, a positive and 10% other negative. So that is called imbalanced data. And imbalanced data generally, uh, example, you can take it fraud detection, medical diagnostic, spam detection. We should know the mathematics behind ML. That is very important, and I thought you should know. So I won't be taking much time. I will simply walk through what happening here. So when we talk about machine learning, we have three main pillars, that is data, model, training, right? So data, each type of data means what sort of data you are getting, that is categorical. Categorical also you can see two type, nominal, ordinal. Numerical, you will have discrete continuous data set. So discrete continuous data set, like in your classroom of 40 student, there could not be 40.4 student, right? It will be completely discrete data. Yeah, some share market data, continuous data. Yeah, could be some binary data, binary outcome, true, false. So categorically, if you can see color red, blue, that is one category. Type of fruit is a different category. Numerical could be discrete continuous, which I just spoke. So here, just to highlight linear algebra, each branch of mathematics that deals with vector, and vector space. So when in machine learning, these vectors are playing major role. So we should know this vector and scalar. So a scalar has just magnitude, any standalone numeric value called a scalar, and vector it will be list of items. So here it could be either row and column, but not together. So in the vectors, we can multiply vector. We can, I guess, in the vector space we can do some arithmetic between two vectors, finding relationship between two data point. So so here So here you can see this vector, like this point they are talking, it is 3, 4. So this is x could be 3 and 4 will be y. And vector is equal to a square root of x. I mean, if you know Pythagoras, x square plus y square under root. So this is what been done here. So to calculate this value, uh, uh, this will be 5. If this is 3, this is 4, then this will be 5. So vector space, this is a relationship between two vector. Like here you can see what uh, summing up to vector. Here you are multiplying with some scalar value, and this is zero vector. This is dot product, and we have cross product. So in the dot product, we are just of multiplying two vector. You're finding relationship between two vector, like how far they are situated. Yeah, what could be the angle between two data point. So here you can see dot vector is equal to magnitude of A, magnitude of B, cos theta. So just think that you can take this example: A is equal to 2, 3, 4, B is equal to this one, A dot B. This is how you will calculate 2 multiply 1, 3 multiply 0, 4 multiply minus 1, and this will come around minus 2. And once you get to know A dot B, you can take magnitude of A is equal to this one, square root of 2 square, 3 square, 4 square. So this is 29 magnitude of A. Similarly, magnitude of B is equal to this one, A square, B square, C square under root, and that will come square root of 2. And similarly, once you know this magnitude of A, magnitude of B, A dot B, then you can find out cos theta. And so when you find out cos theta, it means you will know the the angle between two data point. Similarly, cross product, what is different when we talk about cross product, that will be perpendicular value of another direction. So just think you have x and y, and this will talk about some other direction which is perpendicular to x and y. So A, B, it will go to z direction. So here for the cross vector, you will have a magnitude of A, B, and sine theta. In dot product, you had A, B, cos theta. Here you have magnitude of A, B, sine theta. And this is how you will calculate. Uh, you can see the formula. Then we can go to probability of matrices, right? So matrix also important when we speak when we are going to deal data in machine learning. So that also we should know. So here you can see two uh, cross two. This is null matrix, means it is going to have two rows, two column, and this is three three cross three null matrix where we have three row, three column. Identity matrix, this is for uh, you can say diagonal each one, and same identity, all diagonal will be one here, that is 3.3. Transpose, you can just change the value. Like just think this is the matrix 1, 4, 2, 5, 3, 6. You are changing this is your row and this is column, right? So it has three column, two row. So changing row to column, so 1, 2, 3 will come here, and 4, 5, 6 will come here. That is you are reversing row and column. So I guess this is for today. I will come up tomorrow with a new video where I would be talking about machine learning algorithm. So keep in touch. Talk to you tomorrow. Bye bye.